Hi Rahul, I hope you're well and thank you for accepting the invite. It's great to have you here. So, could you please introduce yourself and share your background for our audience, please?
Sure. Hi, Akshet. I'm Rahul, and I've completed my bachelor's from City University, Ludhiana. And currently, I'm working as a ROS developer in a company called Jetsons Robotics. I've also worked in Auto NXT Automation Private Limited, that's based in Maharashtra, and the main role is to automate electronic tractors. So they produce electronic tractors and they're automating it. And the company that I'm working for now is called Jetsons Robotics. And their main project is to create solar panel cleaning robots that navigate autonomously and they clean the solar panels. We've got a few projects deployed in Dubai, and our headquarters is in Noida, Noida Sector 62. Uh, I've got a passion for robotics ever since I was young. So I created my first robot, I guess, around in sixth class. That was a remote controlled robot. But after that, I gradually stepped up. And 7 years ago, around 7 to 8 years ago, I created an autonomous robot that was using Arduino. It was basically an obstacle avoiding robot using ultrasonic sensors, Arduino motor shield, and a few motors. So that is also available on my YouTube. Yeah. Um, and in the recent times, I've created a lot of new stuff. One, I've got a physical with me. This is a de-authentication device. I've named it Zapnet, and I'm just finalizing this project. This is basically a hacking device. By the way, I also do hacking.
Okay.
So that's something I'm passionate about. But the career that I'm processing is in robotics. So
Okay.
in the recent times, I also created an autonomous robot which can navigate through an obstacle course using a lidar sensor, and it's basically a differential drive robot. I'll be showing that to you in
Okay.
just a minute. So I also uploaded it on GitHub, so it's open source, and anyone who needs some help uh, regarding the robot or making one from scratch, they can use my GitHub repository for making the robot. So it's pretty basic, it's simple, and yeah, that's all from my side.
Okay. Thanks a lot for the introduction. I'm pretty interested in knowing what did you do in the sixth grade? Can you tell us a bit more about it?
Okay, yeah. So basically, that was I took apart a remote control car. I took out all its things, the PCB, the motors, everything. And at that time, I used to have a set called mechanical set, the mechanics. It was basically a part. It was basically a set which contained multiple metallic parts. And from that, I made a base for the robot, and I put the wheels. Basically, I made a car out of uh, a remote control car. So it was, I took out all the working parts, I took it apart, and I made a base using the mechanics set.
Okay.
And that was a remote control car. That was, I guess, my first project in robotics.
Okay, that sounds awfully similar to what I used to do. I used to go and ask my friends if they have a spare RC car that doesn't work and then
Hmm.
take it apart. And it always used to work when you used to separated maybe a few soldering cables have come out or you just solder it back and it works. So that used to
Oh,
be a
that's
cool thing for me.
amazing.
Yeah, so I could just relate quickly. So that's good.
That's great.
So how did you come across your bachelor's? What did you study for your bachelor's, and did you always want to do robotics?
Yes, ever since I was in sixth to eighth classes, I was always interested in robotics. We had a robotics club in our school. I My school was Tagore International School, and uh, we had a robotics club where we started the robotics journey on Arduino's, and we basically had sets for Legos. And there was another thing, I don't remember its name, but those things got me more into robotics. And after a while, after playing with the Lego sets, after winning a few competitions, we started experimenting with Arduino. We had a few classes, a few workshops, which got us interested. And yeah, that was the point when I decided in my life that I would like to pursue robotics for future.
Okay.
And in my bachelor's, my major was mechanical engineering. The specialization was robotics and automation.
Okay.
So I basically went around searching for colleges which offered robotics as a course.
Mm-hmm.
So at City University, I saw it had a course for robotics, but that was just the specialization. My core is still mechanical engineering.
Okay. So,
I've graduated this year itself in July, so I've got my degree. And I'm planning for my master's. I've applied a few places in Germany, in Dubai, also in UK. But let's see, if I get the offer letter, I'll be going off for masters.
okay, that makes sense. And how was your experience studying robotics at the bachelor's level?
The mechanical engineering part was hard. The robotics was easy because I was familiar with it. And in my second year, I got my first job. So it was a remote job. I was working as a robotics teacher.
Okay.
So I was training students on. There was a platform called Bright Chance. So that's where I got my first job from. And I was teaching students about robotics. There was a kit called from STEMpedia called Quirky. So I used that um, to give the lectures online. So I could operate from my hostel room itself,
Okay. So
and that
let's
was
say,
my first job.
got it, got it. Let's say somebody wants to do what you do and teach people on that platform.
Mhm.
How would they go about that process?
Okay, so that was just a normal day. I was scrolling through LinkedIn looking for jobs, and I came across a job as a robotics trainer. So I
Okay.
applied on it. They called me. They were like, "You're too young to apply for it. You're in the second year. We don't take students from the second year. We just take them from the fourth year who are almost graduated." So I was like, I persisted them. I was like, "See, if you give me this job, I will work harder than anyone else." And you could take my interview, you could see how much knowledge I have, and you could decide after that. So they agreed for the interview. They were like, okay, we'll interview you. There are going to be three rounds. The first one would be telephonic round. The second one would be an HR round just to check your communication skills. And the third one would be the technical round. So the first one, that was telephonic round, was pretty easy. The second part, that was the HR interview. That was just to check the communication skills, if you can speak English properly or not, because most of the students are from abroad. So I had
Okay.
students from Dubai, I had a student from Norway, a student from Qatar, all these countries. So basically, the third round, that was the technical round. In that, they asked me to create a project from in their own platform. The platform was Scratch, which was pretty easy to understand.
Okay.
So I was like, okay, let's do it. So I made a project in Scratch and I showed it to them. They were like, okay, good, you understand it. And then I was hired.
Okay.
I would say get the fundamentals clear if you want to get a job, because you can learn during the job itself. I learned a lot during that particular job. And I would say I wasn't a pro when I started it, but when I resigned from that job, when I changed the job, I was good at it.
Okay.
So get your
That's good.
fundamentals clear, get the basics done, and the rest is going to be okay.
Okay. And what did you use to teach exactly?
Okay, so there were modules from that were prepared by the curriculum team. Initially, there was getting familiar with Scratch, getting the students familiar with Scratch, and then it was uh, yeah, there was a hardware kit that was provided to both the two teachers and the students. So basically, they had the same kit.
Okay.
So it was for the students, like for the younger students, it was drag and drop coding.
Okay.
So you interface with the robot, you drag and drop the codes, you change the parameters, and then you make the robot work. So it
Got
was
it.
a pretty good robot. It was, I guess, this size. Yeah, it was about this size, and you could make multiple robots out of it. For example, if you want to make a line follower, it would have IR sensors. If you want to make an obstacle avoiding robot, it would have an ultrasonic sensor, all like that.
Okay. Okay. Thanks for sharing that information. I'm sure it would be helpful for at least somebody.
Hopefully.
And now talking about your project that we're going to discuss today. So what are you going to talk
Okay.
about, and do you have a title for it? And just tell me more about it. How did you come across that idea?
Okay. It's basically an autonomous robot, which is a differential drive robot, two wheels, one caster wheel, and a
Okay.
LiDAR on top. So it maps the entire area with a LiDAR sensor. And what it basically does, it navigates through the obstacles. So with the first thing that we do was, I'll just share my screen. That
Yeah,
would
for
be a
sure.
lot better. Okay, so I'll just share my screen. Okay, just let me know if my screen is visible.
It is now. Yes.
Okay, that's perfect. So this is my GitHub repository where I've uploaded the code. It's called Cypher.f Society. That's the online name I go by. And okay, let's open up the autonomous robot. So basically, this is the robot, and we'll also tell you how it works. So let's say we'll just open up the terminal and type in these commands. These
Okay.
commands are basically for spawning the robot, and these are basically the launch files that make sure that the robot is working.
Okay.
So there are three launch files: teleop twist keyboard to control the robot, and RWS to visualize the robot.
Okay.
Close all this, and okay, cancel. So I'll just open up a terminal. I'll divide it into 5 parts.
That's the
Okay.
Terminator, by the way. It's not the Terminal.
Yes.
So
Okay.
if somebody's not familiar with it,
Yeah, they would be confused. Okay, so we'll just type in the commands, and while I'm typing, I'll just tell you what
yeah.
exactly they are. So the first one is the launch file. So have a look at it. This is a launch file for the robot. The robot is named MyBot. It could be anything, but that has to be changed inside the every folder then. So we are launching the simulation, and we have a particular world that's saved, and that world is full of obstacles. So it's named as obstacles.world, and this is just the uh, path to the, it's going to open up in Gazebo.
Okay.
Gazebo is basically a simulator. It's a physics engine which simulates the reality of the robot. You can put inertia in it, you can put the gravity, you can simulate everything that the real world has. So this is Gazebo. This is our robot with obstacles around it. It also has a camera. The camera is in front of it, and the top thing, that's a lidar sensor. So the lidar sensor is mapping all the things that are around it, and we'll visualize this in just a second. So if we have a look at the next command, it's a launch file that launches Slam Toolbox, which asynchronously launches the uh, toolbox. We've got the parameters file. That's just another location of the file. And this YAML file, that's a parameters file. And we use the simulation time as well.
Okay.
So nothing much here. It just shows that you're registering a sensor as a custom described LiDAR. And for the third one, we use the navigation part. So this is a navigation stack. And again, we'll use the simulation time here as well.
Okay.
And to control to visualize the robot, we'll use RWS. So I'll first make sure this is running. Then we'll use RWS to visualize the robot. RWS is basically a robot visualizer, which tells you what exactly is happening, and you can see the transformations of the robot as well. So
Okay.
if you have a look at the robot, the map that it's creating, it's shown by these white lines. And this is what the robot looks like when the transforms and everything is visible.
Okay.
So I'll just close this for a second, and then we'll run the teleop twist keyboard part. This is to control the robot. So first we have to drive the robot around just to make sure that everything is working, and a map is created. So once a map is created, then we'll make the robot move autonomously. So that's
Okay.
the command ROS2 run teleop twist keyboard, and that's just to control the robot from a keyboard.
But
Okay,
isn't Slam
so
supposed to be, simultaneously localize and map the environment?
yeah, we'll just create a map of the robot just to make sure that everything it knows where everything is, because
Okay.
I did not save the previous ones.
Okay.
The previous maps that I created, I did not save those. Just a second, I'll move this out of the way. Okay, never mind. I'll also put on the hours, and I'll move this to the side. Let's say I'll just make this really small.
Yeah.
Okay, so this is our simulation world. This is what the robot is. This is where the robot is visualized, and we'll be creating a map first. So all the obstacles, all the cones that you see, these are considered as obstacles in this particular area. And as we move the robot, you'll see the map will expand. And as the map expands, more and more white area is showing up, which means the robot is familiar with that particular area.
Okay.
Okay, so with this as I'm controlling the robot manually.
And you're trying to map the entire environment so that it knows where the
Yeah,
obstacles are.
exactly. So basically moving around the obstacles just to make sure it knows where everything is. I can also increase the speed of the robot, but that wouldn't be uh, good for the robot because when it's moving really fast, it's not very precise.
Okay.
All right, so here we are with the map. Okay, so once the mapping is done, we can use the 2D goalpost and we can just, let's say we point somewhere and we want the robot to go there. So if I just do this, the robot
And
would be going there.
okay.
So even in the simulation part, we check the robot is avoiding the obstacles and going to that particular point where we have told it to.
Okay.
And you can also see the camera part in the robot. So let's say if we turn off the transforms. So this is the refresh rate for the camera. So that's why it's fluctuating.
Okay.
Uh, if we close this, and let's say we have to make the robot go to another place. Let's say this one. So we make it go here. The robot, it turns automatically, it sees where the obstacles are, and it reaches that particular place.
Okay. And you mentioned that you created the URDF file for the robot.
Yes, the URDF is basic. It's like nothing complicated. It's just a box with two cylinders on the side, one sphere on the bottom. That's for the caster wheel, and
Okay.
one lidar on top. That's all.
And how did you
And
create
for the
this?
camera, that was an XML file. This is the camera. That's just another box again.
Okay.
So if we have a look at the URDF, I'll just okay. This is where the entire robot is. So if we go to source file, so let's have a look at the description first. So this is where the URDF is stored for the main robot.
Okay.
So we've got some colors, we've got some materials, we've got some colors. We've got a base link. Base link again is the one that's the main base for the robot. That's the box. And then we've got a base footprint link just to make sure that the robot has a footprint as well.
Okay.
Then we've got the chassis. Okay, so here's the main thing. Here's the box, sorry. And then we just add the collision to simulate it in Gazebo. Then we add the inertial macros. The inertial macros can be found from just a second, this one. This is a list of inertial macros that are there. And so I added these here, considering the mass as zero point 0.5. And these can be made as variable as well. So if you're changing something, you won't have to change the entire thing.
Okay.
Then we've got the chassis link. We've got the color of the chassis, that's white. We've got the left wheel link. Again, that's just a cylinder. So we put the cylinder, we put the length, radius, we put the origin, and yeah, the roll pitch here. We've got the color as blue. We add the collision just to simulate this in gazebo again. Then we've got the gazebo reference. We've got a right wheel link. Again, same as the left wheel link, just the other side. Then we've got a caster wheel. Caster wheel is nothing more than just a stair. So we use this as a stair with a radius of 0.05. Again, these can be made as variables. You can like put them up for variables, and you don't have to change it every time you change the robot. We've got
Okay.
the base link. Okay, so again, base footprint link. It's the parent link is base link, and the child link is base footprint. These are the joints. Then we've got the chassis joint to the base link. Then we've got the left and the right wheel joints. Then we've got a caster wheel joint. And after that, we add the LiDAR. I got this from online. I did not write this on my own because I don't exactly know what to expect
Okay.
from a LiDAR sensor. So we named it as a laser joint. It's a fixed link. So LiDAR is basically the red one.
And what resource did you use to write this, or how did you get this code?
I just searched for it. I just searched for it. LiDAR gazebo reference. And yeah, this one, articulated robotics.
Okay, they're doing great work.
Adding a LiDAR, what exactly is a LiDAR sensor? 2D, 3D LiDARs. That's all.
Got it. Got it. Got it.
Okay, so the color is red, just to differentiate it from the wheels. So it doesn't look like a wheel on top. And then we added laser frame. These are basically the parameters that you can change. Minimum and maximum angles you can change. If you like, if there's an ultrasonic uh, sensor that you want to simulate inside this, there would be, I guess, a different thing for that. But when I simulated it, I reduced these angles, and it would act as a laser beam for going from just one direction.
Okay.
So it could act as an ultrasonic sensor. You could also simulate it as a 2D lidar or a lidar that's just looking in front.
Okay.
So we get this file name. I just took this online, and we output the sensor messages, laser scans, and the frame name again is laser frame. Then we put the inertial macros, the one that I was showing you here.
Mm-hmm.
That's from Wikipedia. These are the inertial macros that we put up in this one, just to make sure that inertia is taken care of. So we've got the mass, we've got the radius. So this is basically the formula. If you have a look at it, inertial macros of a sphere. Yeah, this one. So inertial macros for a sphere, a solid sphere. That is 2 by 5 mass into radius square. So it's the same thing that I've put here. 2 by 5 into mass multiplied by the radius square.
Okay.
And these actually are variables. Mass and radius are variables, which are again taken from this, sorry, which are again taken from the core. So we know that the radius and the mass is going to be this particular thing. So let's say for a stair, for the caster wheel, we take the radius as this one, and we've got the mass as zero point 0.1. So we take the reference from this into the inertial macros. That's just for simplifying. We could do it all of this in one particular file, but then it would be a lot of confusion where exactly what we are doing.
Okay. And what exactly is the algorithm behind running this? Did you
Uh,
write the navigation?
no, I did not try and write the algorithm.
Okay. So your contribution to this project, how can it be defined?
Oh, I just made it for practice
Okay.
while I was learning ROS. I still am. I'm not saying that I'm a master of ROS. I still am learning it. So this was just a project to test like what exactly skills do I have and how well I can implement these skills.
And this is ROS2. for the audience.
Yes, that's ROS2. I've implemented this in Humble. ROS2 Humble, that's 22.04. Ubuntu 22.04.
Okay. Any resources
Then
you
we use the
followed
basic.
online, particularly for learning or understanding
Oh
this
yeah,
concept?
this particular tutorial that was from Articulated Robotics itself.
Yeah.
This one that said getting ready to build a ROS robot. So this was one of the greatest things that I used to build the robot.
Okay.
This is from Articulated Robotics, and this is basically a whole tutorial that you need to build this robot.
Got it. Okay. And all of this is in ROS or ROS2?
This is in ROS2.
Okay.
The entire thing I followed it in ROS2, and
Okay.
it was pretty easy.
So how can people get started, to build this? I don't suppose this to be the first project that they do, but
Mhm.
how can they get started with ROS or ROS2 or just robotics?
Okay, basically, if you're trying to get into robotics, I'll stop my presenting. Okay, so if you're trying to get into robotics, learn the fundamentals. Take up courses. There are multiple free courses online. There's YouTube, there's Udemy. I personally learned from YouTube and Udemy itself. And the courses that I took up, the first one was from, I don't exactly remember his name, but that guy, he was a really good teacher. It was basics of Arduino. So
Okay.
I learned my Arduino coding from there. And after that, uh, take up some good classes on mathematics. You need mathematics for robotics. You need mathematics for basically everything. And I'm not saying that you need to be very advanced in maths. I'm not. I still created robots and basically learn everything that's required. Python is required. You could do a lot of things in Python. Computer vision, OpenCV, that's a lot. A lot can be done with Python. So I guess I'll say start with Python, then go on to C, C++, and side by side with Python, do a bit of maths, derivation, integration, trigonometry. All of that is important. And after that, once you've mastered Python and C++, and by mastered, I'm saying once you're fluent with it, once you've gotten the hang of it, switch to ROS. I would say go with ROS 1 initially because ROS 1 is a bit easier than ROS 2. ROS 1, if you have to interface it with, let's say, different components as an Arduino, ESP32, ESP8266, any of those components, it's easier because what you need to do is you just flash the firmware there and you get the data from ROS serial Arduino. But if you're using ROS2, if you're just like uh, interfacing it with different types of hardware, it would be a bit difficult because in ROS2 they've removed the ROS serial part. Now in ROS2 it's micro ROS. So
Yeah.
you have to the micro ROS personally I don't feel it's very good because ROS serial Arduino that was the thing that was uh, very easy to implement. You just put a command ROS serial Arduino and ROS run ROS serial Arduino with the parameters that you want to get the output for, and the any sensor that you're using in Arduino it works. But
Okay.
in ROS2 micro ROS using micro ROS that's a little bit tricky. That's what I felt. I'm not saying everyone's the same. You could go on and try, but I would say start with ROS because once you get a hang of it, you would, and the next time that you switch to ROS2, you would be using micro ROS. Then it would be a little easier for you. But if you're just starting it from the scratch, if you don't have any experience with ROS, it would be a bit difficult implementing those things in ROS2.
Okay. That's good advice. And what advice would you give to someone who just doesn't know where to start or, feel like giving up or just is very demotivated to work in this field? What advice would you give? Have you ever felt that?
I personally have. There was a particular time when I was working on a project. It was basically an amplifier. I couldn't get the chips and the soldering right.
Okay.
So it was after like 2 to 3 tries, I soldered it on a zero PCB. thrice and I wasted the components. I was like, I'm not going to do this anymore. But then something inside me clicked. My parents were like, "You can't give up. Why would you even like give up when you're trying to make something? Make it work. Do it again." So when I did it for the fourth time, it failed again. But the fifth time I did, it was like that wasn't a lot of money spent on it. I guess a total of 100 rupees was spent. So after wasting, I guess, around 100 rupees and four tries, the fifth time I was actually able to make it. Turns out I was putting a pin wrong, which when I desoldered, it got destroyed because that's how the zero PCBs are meant to be,
Okay.
right? You can't desolder it and reuse it. So I would say don't give up, don't get demotivated because eventually, if you keep trying, if you don't give up, it eventually has to work. Uh, my favorite author is David Goggins, and I've read that guy's book. It's called Can't Hurt Me. And it talks about how he was not the smartest in his class. He was like one of the weakest kids in his class. And today, at this particular point, he's known as the toughest person ever alive. He holds a world record of maximum pull ups. That was recently broken, I guess. But he is the only person who's completed the Air Force, the US Navy SEAL, and the army training. He is the only person who's completed all of that. And he was not the brightest, he was not the smartest, he was not the fastest, he was not the strongest kid. If you read his history, you would be really motivated by what he can do. And that's just like pushing past your limitations. So basically, what I'm trying to say is if you don't give up, if the situation sees that this person is not going to give up no matter what, I would have to give in. I would have to make sure that the person gets what he wants. But see, everything is a trial in this life. We do not, we don't get where we want to be in the first try. We have to try multiple times. We have to try, um, even if we don't feel like it. So even if you don't feel like it, no one cares. It's you're doing it for yourself. You're not doing it for anyone else. If you want to be somewhere in life, just make sure you do it. You make sure you do not give up, and you make sure that everything that you do gets counted. Because if you try to do something and it doesn't work, you haven't failed. You've just learned a new way that that thing doesn't work. So all I would say is don't give up, keep trying, and that thing will eventually work.
That is great advice because I agree with that. The For
Mhm.
me, the key takeaway would be to just keep trying, backtrack your steps, and do something
Mhm.
differently every time you try. Try to improve it at least 1%, because if you do the same thing again and again, you can't expect it to magically work. So,
Exactly.
to just backtrack, because I have done that in the past and it has worked for me.
Mhm.
I came till the end, 98th step out of 100, and everything failed. And all I did was just go to step 0 and then try it again, and then it
Try it
worked.
again with a
And
different method.
what we observe is that when you try it again, you can do it faster and you can do it better.
Mhm.
So
That's
it is
actually
never a
true.
loss. So I think that's great advice. Thank you for sharing that. So what's next for you? What are you planning to do? Are you planning to work, or go for higher education, or what's next?
I'm planning to do my master's. Let's see if I get the offer letter this year, then that's good. But I've also had a few suggestions from my mentors and my friends that if you do the master's just after your bachelor's without working experience, without any work experience, you can like go for it, but that wouldn't be very useful because that's again just like a bachelor's degree with a bit more knowledge. What are your thoughts on this?
I believe that work experience before bachelor after bachelor's will definitely be more helpful, but
Hmm.
there are, so it is circumstantial and it is individual specific what way, you we can't generalize this thing. But
Okay.
for me, if I had the freedom to do something like that, I would definitely wait for a few years, maybe 1 or 2 years or 3 years of experience, and then go for my masters. That would give you a better idea of, what you want to specialize in, what are you inclined towards, what do you want to learn more about. Most of my classmates were maybe 25, 26. Some of them were even, in their early 30s. So I
Okay.
think that's the sweet spot to between 25 and 30 is the sweet spot to pursue a higher degree, because you already know that this is how things work in an industry, and this is what you need to learn to improve them, and that's how you grow yourself, and then you can contribute to the industry in a better way. When you go after your bachelor's directly, you basically don't know what's going to happen, and you can't know
Hmm.
how to contribute in a more efficient way. So for me personally, I think working before your masters is a good thing.
So basically, getting to know what's going on in the industry and what's like uh, what does the market require, and working based in that,
Yeah.
and learning more based in that. Okay, so that's a good thing. So what I'll probably do is I'll work for a few years in the same company or not in the same company. That time will tell, because we never know what's going to happen next. But basically, I'll be working as a robotics engineer, and if I get the opportunity again, I would be going for my masters,
Okay.
because there's no age limit for masters, right?
Yeah, absolutely, yes. I think
Okay,
that's
then
good.
that's great.
Because working before your masters will open up multiple doors for you. Maybe you come to realize that masters is not for you, or you could do something else instead. Maybe go for a
Mhm.
PhD directly, or try something entrepreneurial. There could be so many different ideas. But pursuing masters directly after bachelor's will probably restrict you from doing a few things.
All those things that you just mentioned.
Yeah. Okay.
That's a great advice.
Thanks. I keep on realizing these things with time. B- There's no right or wrong answer to this. It's just
Hmm.
that what could be
You
right.
have to find your
Yeah,
right.
you have to find your right. Yes. So thank you for sharing your thoughts. Thank you for the great advice, and I'll take all the resources from you that you mentioned and
Sure.
link it to the descriptions. And wish you the best. Thank you once again.
Thank you so much.